Okay, so good morning, fellows. Today we're going to prove the formula for the dot product of two vectors. But before we start this thing, let's look at something. One property of dot products. When I have two vectors A, in fact, when I have a vector multiplied, I mean dotted by itself. What I'm trying to say is if I want to find the dot product of the same vector with itself, it's going to be equal to the square of the magnitude of that vector. So what we're going to do will actually involve something like this. So let's start. To begin with, we need to go to the Cartesian plane, which is this, the XYZ plane. So let me say that I have my Cartesian plane this way. The coordinate plane. So this is my x axis, this is going to be my y axis, and this is going to be my z axis. So I'm just illustrating this on the three-dimensional plane. Now this is going to be my center point, which is the origin, and so I'm directing, let's say I have a vector which is directed from one point to another in the plane. So let me name this point A and this point B. The vector that is between A and the origin, that is the relative position of A with respect to the origin, gives the vector OE, which is written as this. I'm going to denote it by the small a. Then I relate the point B with the origin, and so that's going to give me a position vector B. Okay, so that is the vector B. Now I'm going to refer to this vector as vector AB. Now notice, OA is a position vector, and that is A. Now OB is also a position vector, and that is B. What I can get out of this is AB. That is the displacement vector from the point A to the point B. And that is given by the position vector OB minus OA, and that is equal to B minus A. So this whole thing here is this vector from A to B is going to be B minus A. So let me note that. Now at this point, I want to locate an angle that is existing between the two vectors A and B, or OA and OB, right? So how do I find the formula for the dot product? This is what I'm going to do. I am first going to relate everything that we have in this triangle with the cosine rule, our Cauchy's cosine rule. Now, when I have minus B, the modulus of B minus A, according to cosine rule, this side, the length of this vector, which is B minus A, the length of that vector, is going to be the square, in fact, the sum of the squares of these lengths. That is, the length of vector A squared plus the length of vector B squared minus twice the length of vector A times the length of vector B times the cosine of the angle between A and B, which is theta. And so let me note this as equation 1. I'm going to just name this as equation 1. Now, how do I relate? We know that when I have, from this idea, I introduced this. When I have the dot product of a vector with itself is equal to the magnitude of the vector raised to the power 2. That is the square of the magnitude of that vector. So when you find the dot product of a vector with itself is equal to the square of the magnitude of that vector. So what I'm going to do is, by this, I can say that the magnitude of B minus A, over here this is going to be a square, don't forget. The square of the length here is equal to the sum of the squares of these lengths minus twice the product of these lengths times the cosine of the angle between them. So that is established. I made a mistake in not writing the square. So let's come back to our idea. From this property of dot products, I can say that the magnitude of b minus a all squared, relating it from the right, is going to be just the same as b minus a dotted by itself, and that is going to be exactly this. I get in it. And so if this is what we have, this is going to be equivalent to b. We are taking the distributive law, and so we're going to take each one of the components to multiply this, and that's going to be vector b dotted by b minus a, and then the negative of vector a dotted by b minus a. Now at this point we're going to have b dot b, right, vector b dot b minus b dot a minus a dot b, right? Then of course this is a plus because we have two negatives, plus a dot a. What does this give me? Don't forget, everything we have on the right is equal to vector b minus vector a all squared. In fact, this the magnitude of that. The magnitude of vector b minus a all squared. So at this point we're going to have the magnitude of b minus a all squared will be equal to, okay, this thing here is going to be equal to, based on this property, this thing here is going to be the magnitude of vector b squared. Then minus, now look at something. Dot product of vectors is commutative, and so the magnitude, in fact, sorry, the dot product of b on a, the dot product of b with a is equal to the dot product of a with b, sorry. So b dot a is equal to a dot b, in terms of vectors. And so this is just exactly the same thing, and so we have twice of the dot product of a with b. So this is exactly equal to that. And of course, based on this property, we still can write this even exactly a dot a, and so we still have magnitude of a squared. So we can realize that this is exactly what we have here on the left hand side here. It is just the right hand sides that are different. Since this is equal to this, the left is equal to this. Let me name this equation 2. And so since in equation 2, the left hand side is equal to the right hand side of that in equation 1, we're just going to equate the right hand sides. Of course, once the left hand sides are equal, the right hand sides must also be equal. And so that means that since equation, left hand side of equation 1 is equal to left hand side of equation 2, I can say that the magnitude of a squared, reading from equation 1, plus the magnitude of b squared minus twice the magnitude of a times the magnitude of b cos of theta is going to be equal to what we have on the right hand side of the equation 2. That is magnitude of I'm going to rewrite this by starting with magnitude of a squared, right, plus the magnitude of b squared minus twice a dot b, right, and that is what we have. Now if this is equal to this, let's try to make some important cancellations. Since we have a squared, the magnitude of the vector a squared on both sides, and the signs are the same, we can just cancel them out. They have cancelled out. This is also just equal to this, and so we can cancel them out. And so we are left with this quantity to be equated to this quantity. That means that minus 2 magnitude of a times magnitude of b, right, cos of theta is supposed to be equal to the negative of twice the dot product of A with B. And so at this point, of course, the negatives have cancelled out. And so we have, of course, the 2's too have cancelled out. And so we have the magnitude of A times the magnitude of B times the cos of the angle between them is equal to the dot product of A on B or with B. So we can just equally write A dot B equals the magnitude of A times the magnitude of B times the cosine of the angle between them. That means that if we have any two vectors and we know the angle between the two vectors, we can simply write the dot product as the product of their magnitude and the cosine of the angle between the two vectors. Thank you.